Hello, my name is Craig Savage, and today I'm going to be talking about doing Data Viz with R. This talk is part of a joint talk for a meetup entitled Doing Data Viz with R and Python. This presentation is just the R part. As a brief outline of what I plan to cover is I'm going to talk about some different data visualization techniques in R, including ggplot, interactive plots with ggplotly, leaflet highcharter, reporting and documenting with rmarkdown, including these slides. These slides are all done in rmarkdown, so this isn't PowerPoint or Keynote or anything. All of this is R code. And then talk about interactive data with Shiny, spending some time talking about the differences between what you can do in rmarkdown and what you'll need to do with Shiny. Then I want to look at visualizations regarding the impact of COVID on Australian jobs and wages. There's geographic data from the ASGS, which is the Australian Statistical Geography Standard. I'm going to be looking at what's called SA4, or Statistical Areas Level 4, and the Australian wage data is indexed to the 14th of March, where everything is normalized to 100, and then we look at the evolution over that. If you want to get the code for these slides, that's available on GitHub. The URL is there. You'll need R, of course, and I use an ASGS package. That's a little special because it packages up all of the ASGS data. It's quite large. It's about 800 meg, so you don't install it in the normal install.packages way. You use an ASGS.foyer. I'll try to include some information on that in the description. And of course, I recommend you use RStudio rather than the R interface, but that's up to you. If I look at the data, here's a quick snapshot from the ABS. It's got the state, the statistical area 4, the SA4, and then a list of weeks with the job index, the wages index per week in each column, where every row then is the SA4. Talking about that and how I'm going to convert those data into something for my visualizations, let's talk about data wrangling. And in particular in R, there's this concept of tidy data, where every column is a variable, every row is a record, and every cell is a value, which is loosely speaking the same as a long format. So the data I have, if I go back to that, this isn't tidy, because here my date variable is in fact the column name. So I'm going to make it longer so that I have, if you imagine this being the state, the statistical area 4, the first one here being Hunter Valley, excluding Newcastle, and then the 4th of January 2020. Dates are in day, month, year for my friends in the US. And then the value 93.7. The next row would be New South Wales, Hunter Valley, 11th of January, 96.2, and so forth. This is what I mean by long format. And so I'm going to use the tidyverse package, and in particular pivot longer and separate, because my data here have the state ID 1 in this case, New South Wales, and this New South Wales, not New South Wales, and then 106 being the SA4 ID, and then Hunter Valley X Newcastle, etc. So I'm going to go through using the tidyverse to get my data in the proper form to do the data visualizations I do later. Some primary goals is I'm going to be talking about visualization. I'm not going to be focusing on the data science. So I'll be talking about some code and I'll use some time series, but if you're a time series buff and you see me using auto or Rima and pretending like that's enough, yes, I know better, but the goal here is to demonstrate some of these features of R and doing visualizations in R, not to have proper data science per se. And we're also going to talk briefly about the code to generate the visualizations. The talk is going to flow with the slides, with the visualizations, then a detailed diagnosis, a detailed description of the code, and then the next section. So if you're interested in the code, and only the code, the timestamps are below. If you're interested in the description and not the code, you can skip ahead. The concepts I want to talk about is most of the R visualizations are actually interfaces to a JavaScript API. So things like highcharts, leaflet, data table, all of these are JavaScript libraries that I can pass data to and from with R. I want to talk about the differences between your visualizations being printable or HTML. And finally, this distinction between rmarkdown and Shiny, whether or not you can pre-compute everything or if you need it to be dynamic. The secondary goal is to have fun. In my opinion, if you're doing data visualization in your spare time on your terms, you should be having fun with this, or else maybe reconsider if there's a different area of data and analytics that would be better for you. So starting with the general setup, there's a number of libraries that I'm using within R. Read Excel to get the data, Lubridate for dates, tidyverse for general data manipulation. This includes dplyr, ggplot2, tidyr, per, etc. Plotly, rmarkdown, knitter. Knitter uses the knit child, so when I talk about using rmarkdown and using it in a sort of recursive fashion, knitter is used for that. Shiny, leaflet, highcharter, dt, sparkline, and then forecast for the time series manipulation. Moving into the data, I have this jobs SA4, which I'm getting from Excel. It's in the second sheet at that range. I've renamed the state in SA4 to be the first two columns, and then the pivot longer, as I was talking about the data being made tidy, rather than using date as that column, I'm going to swivel it longer. So date I've converted from a character to a numeric. This is one of the fun things about using Excel, the origin of which is December 30th, 1899, just because. And then I'm using the separate, and what the separate's doing, if you remember my data, is I had the number and then the state name, and the number and the SA4 name, such as 1 New South Wales or 106 Hunter Valley excluding Newcastle. And what the separate's doing is it's taking this one column and splitting it into two. In this case, I'm taking state and separating it into the code in the name, the SA4 and separating it into the code in the name. And if there's more than one, that is, if there's extra little things that would normally denote another column, such as a dash, Hunter Valley dash excluding Newcastle, or Sydney dash inner, I'm saying rather than converting that into 3 or more, take the number, make that your first one, and whatever text is there, merge that together to the second one. And then for job state, this is me rolling up the information from SA4 to the state level. Because I have the state name, I'm grouping by that and the date, and then taking the mean index as the mean of the index. Yes, I should probably weight it by something, but for purposes of this demo, this is good enough for me to make some of these state level graphs. And then finally, I've taken that and rolled it up into Australia by introducing a new state named Australia and looking at the mean index there and binding them all together. So if I want something where I have the Australian data and the individual state data, it's in one location. The other thing I'm loading is population data. These data are set up a little bit differently. For these data, every population is in a separate tab rather than all in one tab. So in this way, I've created this function to read Excel, grabbing an input sheet number, loading the columns based on the types here, many of which I'm skipping because I only really care about the SA4 information, and then filtering all those data, making sure I remove the missing values because there will be a disclaimer at the end or some text or a blank line, grouping by the state information and SA4 information, and then summing up the population. Then using mapdfr, and what that's doing is I have the sheet index of 2 to 9 being the different sheets, one for each state and territory in Australia, and for each one of those values I'm calling to load the getPopData function which I've created, and then binding it all together. And finally I'm taking the data from the SA4 2016 and joining that onto my full pop data based on the state, index, name, SA4 index and name, so that now my geographic data has a population at the end. So now I want to talk about some initial plots, starting with ggplot, making it interactive with ggplotly, and then using Shiny and rmarkdown. Starting off with ggplot, if I look at the state level variation with time of the wage index, we see a climb following the new year until it levels out. COVID hits. Australia recorded our 100th case of COVID on the week ending the 14th of March, so you see this precipitous drop things recover, it drops again for Christmas, New Year, and then it comes back up. So this is the basic data. If I mouse over things, this is a static plot. One of the features of ggplot is it does produce these image type plots. There's no interactivity, so if you're using PowerPoint, Word, PDF files, ggplot is a good place to start because it's printable. The next thing I can do is I can augment that using the plotly package. There's a function called ggplotly, and all that does is augment so that now I have mouse over information. I can deselect or fully select individual states. The black line is the Australian average, and I can zoom, and all the other things that I can do with plotly type plots I can do here with my ggplotly. It's quite simple. If you have a ggplot object, you call ggplotly and you get all of the benefits here. Moving on with Shiny, even though this is a ggplot and it itself is not interactive, with Shiny it creates an image map, if you will. So here I've relabeled things from dates to weeks, going from 1 to the number of weeks here, which is about 65. And because it's an image map, I can associate the x-coordinates of my plot with positions on the image. So here I have in the top graph the base time series, the base history, and in the bottom I have a forecast using AutoArima of taking the whole series and forecasting forward. And so you get that fan with the confidence intervals of 75 and 90%. And you can say, well, that's nice, but I want to only focus on this little bit of area representing the new year and COVID new normal. And doing that and saying, right, I only want to use these few data points, which again, all you time series fans, yes, I know better. But for purposes of illustration, I can select what type of data I want to use, how much of the data I want to use, recompute the ARIMA model based on that, and redo the forecast. And those of you who rightfully say, well, you need to use more data than that, I can go back to after the COVID drop, there at week 15, and use all of that data and get an updated forecast. And so in doing this, if I want to be optimistic and say, well, I don't want to include the Christmas drop, that seasonality, which I only have one time period here. It's not enough to really do the modeling. If I just want the COVID recovery period and use that for my forecast, I get this bottom graph with things still increasing. This also has the advantage of being a nice story. So then I can go on to my next plot. If I'm happy with this, if I'm happy with the story, if I'm happy with the forecast model as I have it, here's that model in greater detail. And I can build slides here because using HTML for talking to my fellow data visualizations is nice, but at the end of the day, some people want PowerPoint. And so I can use this build slides function to take this graph and send it to a template, which in this case is 2 slides, a title slide and a placeholder for a graph, and I'll insert this graph. So I can use rmarkdown as a function in a way that I can have a template document and populate that template with information that I pass in as if my documents were a function. So talking about the code here, this is the rmarkdown I'm using to generate those slides, to generate the plots that I discussed. The first plot, the ggplot example, calls ggplot with the data with the job state. Remember, this is by state. And I want to illustrate 2 things here. First, the automatic assignment of colors in that first line. The way ggplot works is you have your initial plot call, and then you add together subsequent layers. And this is going to come up with most of the other visualization tools I talk about. The idea that you have this base case, and then you add layers. So starting with my job state data, the next thing is to add a line, geom line, with data on the x-axis, the mean index on the y-axis, and color being the state name. Now originally I was going to use my my aggregated data that had Australia as its own color, but I decided against it because I wanted to demonstrate that you could do this multiple times. So then I add another line separately using my Australian data, again with the same basic aesthetics. X is date, Y is mean index, color is Australia, hard-coded black, line type is 2 to make it dashed, and size is 2 to make it bigger. So in this way I have my state level information being assigned, and then I'm using a different data set to add that second line. That's why things don't line up as well when I call ggplotly with it. And then my labels, date, wage index, etc. I put the legend on the bottom, and then there's my first plot. The first command assigns the plot, and then calling first plot itself displays it. The second example of ggplotly, as I said, it's quite straightforward. You call ggplotly a first plot, and that generates all the other information, fortifies it with the HTML tooltips, etc. For the Shiny interaction, it's a little bit more involved. I'm using what's called reactive values here, and what that means is I want the data here to react to some event. In this case, I have render plot, which means I want to make a plot which is ggplot with the jobs, the Australian jobs with row number by week. Remember, I redid the axis, so that would be week rather than date, with the mapping that X is the week, Y is the mean index, with the line that's black. And my base plot I had be that plot. And then I have these output arguments, and these output arguments are what enables me to brush the plot. So while the plot itself is fixed, the fact that I've rendered this plot with these output arguments, which is a list that I can brush with an ID called plot brush in the X direction only, and 250 points is the height of my graph. Underneath that I have another render plot, which says if nothing's brushed, then the date range is the whole thing. And if it's not null, if I have brushed something, to look at the floor of the X-min and the ceiling of the X-max. So that gives me this nice bracket of what data I want to use for the next part, which says use that mean index range as your time series, make the auto-arima based on that, make your forecast based on that, and then take my base plot, which I had saved before and made reactive, and add a layer onto that to then display. And because that's a reactive value, it's still sitting in memory, if you will, so that when I get to the rmarkdown publishing and I render a plot, which is my forecast plot, which I've set to a height of 400 pixels, and then I have this button that says go. An observe event just says wait for that first argument, the input -go, to change, in this case for me to press it, and then execute the next part, which is to render that PowerPoint with a parameter, the parameter being the plot. And if I look at that, here's the PowerPoint that came out of it with two things, the title and the plot. In the lead up to the meetup event, we had a survey of what types of data people might like to see, and many people said they'd like to see spatial data. So I'd like to talk about some visualizations using maps in R, in particular the leaflet package. Now this package is one of these packages that lets you interface to a JavaScript package, in particular leaflet.js. And the way this works is use the dplyr pipe, or the magritte pipe, which is this % greater than %, the forward pipe, which is pronounced then. So if I'm going through some code and I say leaflet of SA4 data, then whatever, then refers to this pipe. And when you're piping things together, often it follows a similar pattern to ggplot, in the sense you have some base plot and then you add layers. It's just you'll be using pipes, not pluses. Perhaps one day there will be a ggplot3 where everything is piped together. And Leaflet does this, and most of the other JavaScript libraries also use this pipe. I don't know if it's a particular feature of JavaScript that things are set up this way, but that's how it works. Later on I'll be using high charts and data table, or DT. That's different from the data.table. Data loading and manipulation in R, so be careful with that. And in addition to that pipe, a lot of the arguments are set up as lists. So if you go to the JavaScript documentation and you see you have various options you can set and sub-options, that's generally done with lists, and we'll talk about some of those options later. So if I start with my leaflet, you can start by using the ASGS data and add polygons. Now here I have SA4 polygons, and sitting here with no real context, I have this nice map of Australia drawn out for me. All of the borders there are the borders of the statistical area 4. They're meant to have between 100 and 300,000 people. Various differences. When you look at the outback, you can get these very large areas with very few people. So that's the first step, is I have these polygons that represent Australia. Next I can add tiles, and here I've used OpenStreetMap, and that gives some context to this. So now my tiles of Australia, or my polygons of Australia, they're Latin long, mean something. So here I get this nice view of Australia in the context of the world, with New Zealand, Indonesia, Malaysia, etc. And from here, if I zoom in, the OpenStreetMap has quite a lot of detail. And as it redraws everything, you start to see state names, you see geographical features like the Great Australian Bight, large cities like Melbourne, Sydney, Canberra. I've included the names of the SA4 regions, so we can see Ballarat, Shepparton, Bendigo. If you're not from Australia, you might not know any of these places. And as I zoom in further, you start to see roads, and we can zoom into downtown Melbourne and get quite a bit more detail to see the CBD and some of the areas around Melbourne. And all that works with these open source tiles. Again, this is OpenStreetMap. There are others. Then the next step is, because I have this job data by SA4, I can use those values to create this color map of Australia. Now this is data from the 8th of August 2020, and something about the 8th of August is during that time Melbourne was still in lockdown, whereas the rest of the nation had mostly opened up. And as I mouse over, I see the wage index is almost back to where it was on the 14th of March. But if I zoom in on the Melbourne area and Northwest Tassie, some of that is still in the red, and as I mouse over, we still have numbers less than 100. Fortunately, once you have the SA4 data from the ASGS, the code to do this is quite simple actually. Starting with the first one, where I'm talking about making the graph and then adding the polygons, I create this object called leaflet polygon, which is leaflet SA4 2016, which comes from the ASGS. Then add polygons. Here I've made them black with the weight 1, and I have some highlight options set up with the colors white, the weights 2, and bring it to the front so that when I mouse over an SA4, it pops a little bit, which I then render. Going to the second one, adding the tiles, it's pretty much the same as before, leaflet of SA 2016. I put the add tiles in there, and I've also made a label to paste the SA4 name. Now because the SA4 name is part of that data frame that I passed in, or the data structure that I passed in, it is smart enough to figure out that that's what you mean. The little tilde there says, go look for this in there, and then I render it. Now as you can see, there's very little change between the two. There's the addition of the tiles, which I've piped in, and then I've added the label. For the third plot, it's a bit more involved, because here I've taken my jobs SA4 data and filtered it to the 8th of August 2020, which I've then joined together with my data from the SA4 data from ASGS. And then I've only selected the name, the date, and the index to make it a little bit smaller, joined all that by the SA4 name so that it matches. I created this color palette, which is red, yellow, green, so that small numbers will be red, meaning that the wages haven't caught up to March 14th. The domain is the index there, so that red is the bottom, green is the top, split into 10 bins, if you will, 10 color gradient marks. So then leaflet jobs is leaflet SA4, add tiles, add polygons. Again, the color is black. If you highlight it, it's white. It comes to the front. But here I've changed the labels from not just the SA4 names, but also the rounding of the index. And I've made the fill color according to the palette that I defined of the index, so that low numbers are red, high numbers are green. So next I want to talk about reporting with rmarkdown. Again, rmarkdown is quite powerful. These slides are rmarkdown after all. And the basics is it's similar to a Jupyter notebook, if you're familiar with those. It allows the combination of written text and code. And the jargon in rmarkdown is that these are code chunks. And while rmarkdown is designed for R, you can use other engines such as Python, SAS. There's about 14 different engines you can use. So while it's called rmarkdown, if you wanted to call it PyMarkdown, that wouldn't be too far off. There's a list of outputs, such as I/O slides. This is I/O slides. HTML documents, which I'm going to go through in an example. PowerPoint or Word. Of course, then you need to have PowerPoint or Word installed. And then PDF. PDF works through LaTeX or MikTeX if you're using Windows. And so while HTML you can do regardless, it's kind of built in. Using some of these external file formats like PowerPoint, Word, or PDF does require some external help. So here's an example of an HTML document. Now, because my slides are HTML, and I can build an HTML document with rmarkdown, I've embedded my HTML document in my slides, which seems a little funny, but it allows me to interact with it because it's HTML to HTML. So here I have a high chart, which is the wage index of each state. And as I mouse over, we get some information about what's going on. We can see the Victoria and Tassie being depressed relative to the other states as we get in through July, August, which is the map I showed earlier, etc. Pardon me. Now, another thing I want to talk about is with this rmarkdown document, now I've taken the data and I've passed it in as a parameter. And I can further take that and manipulate it in such a way to look at subsets of the data. In particular here, overview is my top level. And then for the next level, here I've organized it into tabs where I have ACT, the Australian Capital Territory, or Canberra, and I have the historical index and the last month being 99.23. So it's pretty much recovered to about March last year. The other ones have a little bit more. There's 14 for New South Wales. I've split out Sydney because there's 14 in Sydney and I didn't want all 28 in one tab. Because this is a data table, that's a DT, I can do things like organize, I can search. If I search for Newcastle, there is no Newcastle in Sydney. If I go to New South Wales and search for Newcastle, then I get Hunter Valley excluding Newcastle, which was the first row I showed earlier, as well as Newcastle. And so I can use a number of these tools to break apart my data and look at subsets of it in a very standardized way. The other thing I have is this code tag, where if I click it, I get the code. Remember, an HTML document, or sorry, a rmarkdown document with an HTML output is similar to a Jupyter notebook where I have code chunks, and if I evaluate this code chunk, now here I have params job data, param being an input to my HTML or to my rmarkdown document, which produces the HTML. And when I execute that code chunk, I get this chart. So in this way, it can be quite convenient if you're talking to management who doesn't want to see the code, and you show them this, and someone asks, well, where did that come from? You can look at the code and go through it. So this is a bit easier because I don't need to resort to screenshots and otherwise sharing my code with you because it's all embedded. And so if I show all code, my state plot data, I'm grouping by state and date and looking at the average of the index. Perhaps I should be weighting it, but for demonstration purposes, this is fine. And then my chart is that data. I'm making it a line chart. And then HCAES is similar to the aesthetics from ggplot by design. ggplot is one of the first things you learn when you learn R visualization, and so many of the other visualization tools try to emulate it a bit. And here I'm saying I want my x-coordinate to be the date. Remember, I grouped by date for my state plot data, y being the mean index, and then the group being the state name, so that every state is its own group. And then HighCharts is smart enough to say, well, then I'm going to coordinate it based on its color and shape. The title gives me the state level time series of wage indices. Note I'm using pipes between all of these commands. And then for the tooltip, I have it being a table. And all that means is if I mouse over any individual line, it shows me all of them, and 2 decimal places. And then calling HC state populates the chart. More subtle is the way I've structured the tabs. So I've created this function called makeStateSlide, which perhaps I should call state tab, but never mind, which looks at a template rmarkdown document, state child. And what this is doing is it's saying, well, I'm going to create this environment, I'm going to put the state data in there, and then I'm going to call that template and knit it and return it. Now what that rmarkdown document does is render this data table. I'll put up an example here of what it's doing. It's really quite simple. Remember, overview is the top level, and I've told it at the top level, I've told the rmarkdown to have a tab set underneath. So everything that's 2 levels, that's the 2 hashtags, will be collected together into a tab. So here I've said, well, if I'm using the big city, give me the name of the city. If not, give me the name of the state. And that's why, looking at these tabs, I have the states or territories, or Sydney or Melbourne. So I've segmented out what information I want by the subset of Australia. In this case, the big cities, Sydney and Melbourne, and states and territories. And I've put that in a separate file so that then I can call that file multiple times, which is what this sublist is doing. It's saying, right, split up my input data into states and the big cities. Then for each one of those, which is this map command, this is in the tidyverse, this is per package. For every element of that list, make the state slide and then concatenate them all together, with the separation being the return. And as a result, this scales. So if I wanted to split out Brisbane, I wouldn't need to manually go in and change things. I would need to change the big city to not just look for Sydney and Melbourne, but to look for Sydney, Melbourne, and Brisbane. What I want to stress from a kind of R programming point of view is you can start to use tricks from coding in your documents. You can pass data in, you can pass parameters in, you can pass in parameters to use to render or not render certain parts of your code. You can send in lists. So if you had, if you going back to my PowerPoint where I passed in a single slide, if you passed in a list of multiple slides with, say, a title and a graph element, you could make any number of PowerPoint slides with titles and content therein by passing in the list. Finally, note that all this is pre-generated. It may be interactive in the sense that I can get information from tooltips, I can select different states, I can look at these spark lines for each part, but it's all done. All of this is computed in the background and it's fixed. I may be able to navigate around it, but it's fixed. So on the back of considering having fixed data in the background with our Markdown, I want to talk about interactions with Shiny. Shiny apps in general have three parts: a UI, loosely speaking your front end, a server, or back end, and global. That's data that's shared amongst both the front and back end. So a lot of times the global processing is things like loading data or establishing constants, etc. Now you can customize how you want to arrange the inputs and outputs. The Shiny app I had earlier had two plots. There's a number of pre-built widgets, like having drop-down menus, numeric input state ranges, and most packages will have these paired output and render functions. So you'll have a plot output in the UI and a render plot in the server. The leaflet data had a leaflet output and a render leaflet. High charts have a high chart output and a render high chart. So you get these common patterns to link up things between the front end and the back end. So here I have a simple Shiny app. On the left I have a high chart, and on the right I have a GG plot. Now again, the high chart is somewhat interactive, and the GG plot isn't. And so this is that time series example earlier where I said let's just take the time since 2021 and look at those data. And I think we can agree that that's not enough to really do a forecast. So I've put some extra points. Now initially those extra points are the basis of the forecast as shown here on the right. But if I get an expert and say, well, how do you think things will evolve for the next 12 weeks? And I can move these points. And upon moving the point in the GG plot changes. And if I make this slowly increasing based on some kind of random walk up, I can expertly set some kind of forecast. And as I'm doing this, you can see the GG plot updating, giving me a new forecast based on the data. And it's kind of illustrating my point that this isn't a good idea, because if I take this last point and move it around, the mean forecast can swing a great deal. But this gives you another way to interact with your stakeholders rather than saying, well, give me 10 forecasts and let's hypothesize different growth rates and do Monte Carlos. You hand them the graph and say, here, play with it. Look at the sensitivity. Look at how little we know about this forecast, because if I take this one point and change it, then my forecast can change considerably. And it's also a good test because if I leave that point there so that things have this nice growth to it, or if I bump it up a little bit, I don't think anyone can really tell the difference, but now my forecast goes up faster. This is good news, and it's a good test for whether or not people want to look at the result and use that result to define your model because it's politically convenient, or do they want to look at the variation of the model and say, okay, I can see those wide confidence intervals. I can see that the forecast isn't exactly stable. Let's look at some other means, whether it's fully expert judgment or something more sophisticated than an auto or REMA, to figure out how we should forecast. And again, I want to stress that here the data aren't pre-computed. You can move those points wherever you want. If I take this and move it way up here, I don't think that's a very good idea, but there's nothing stopping you from interacting with the data this way, and you're completely on your own. You're able to break it. I've put very few constraints as to what you can and can't do. So by changing the underlying data and by having the flexibility to change it in whatever way you'd like, you can't pre-compute that. And so everything here is dynamic and is being done in real time based on the settings I give it. And that's the big difference I want you to understand from this. Oftentimes I'll see Shiny being used as if it's a BI tool. If you really just want a BI tool, consider using our Markdown. if you have some large number of options, some large number of computations where you want to look at SA4 by gender, by industry, by etc., 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 and the combinatorics would kill you, then using Shiny as a BI tool is fine. But actually, Shiny can do much more than that, and conversely, rmarkdown can do quite a bit, so long as you can pre-compute things. So the code here for Shiny is broken into three main parts: a global, using initial data and other parameters, a UI, which defines the front end, which in this case is those two plots, and the server, which is all the computations on the back end. Quickly note that with the high charts, in order to use draggable points, there's a module to use that by default is commented out in some versions of high charters, so make sure you go and double check that. It should be uncommented as it is here. And talking about the global, it's some of the things we've done before. The interesting one is this function that I've defined. This is a JavaScript function, and in particular there's this Shiny on input change called HCMove, which says if something in the graph changes, flag this thing called HCMove and the Shiny side. And Shiny is built on HTML and JavaScript at the end of the day, and this is one of the few cases where I find some JavaScript that works and I use it. And I can kind of read what's going on, but if you asked me to reproduce this, I'd struggle. One of the good advantages to using Shiny is, for the most part, you can get by with R code. So looking at the global part, this first bit for the Shiny app command, what this is doing is my basic gathering the data, making these 12 dummy points, which I'm calling next data, and then the forecast. The UI is a few lines. It's this H2 flag of interactive forecasts and two plots. The Shiny server, the back end, is a bit more. So there's two outputs. The first output is this HC movable, which is the high chart. The second one is this output GG forecast, which is the GG plot, which again takes in the updated information from moving the points and updates your forecast. The key point here is this middle bit, this get next data, which is reactive. And what that means is if any of the reactive elements inside it changes, it will invalidate and recall. And here I call input HCMove, which is exactly what my Shiny on input change was in the global part, which basically says if any of those points are dragged and move, then it won't be null. Then gather all the data together and return it as next data. So that in my GG forecast, I'm getting next data, checking to make sure nothing's changed. If not, nothing happens. If something has changed, then my update data, which is the binding of my historical data, which is fixed from global, and next data will update my forecast model, will update my forecast data, will update my plot data, and will make the plot accordingly. Now, because the only thing in there that's reactive is this get next data, and the only thing in there that's reactive is the input HCMove, none of that will change until you move one of the points. If you're used to React.js, it's similar. I'm not going to go through the high chart and the GG plot in great detail because I've covered the basics of how those work in the section about rmarkdown for the high chart and the GG plot at the beginning. So very quickly, some conclusions. I've talked about data visualizations, and here's another high chart. Here I've got population on the x-axis and the wage index on the y-axis. And I've enabled the tooltips so that when I mouse over, it tells me the population and the wage index of whichever SA4 I'm looking at. So this is the Gold Coast and Queensland. It's showing me all the other Queensland statistical areas here, and I can mouse over and see Victoria's still struggling a bit and everything else. And in making this plot, there's no real reason why I wanted to see population by index. And it's a little misleading because some of these Melbourne ones are larger than the New South Wales ones, even though Sydney is bigger than Melbourne. And in looking at these graphs, it's hard to know what types of graphs to make, what people want to see, and left to my own devices, I do confess that I tend to customize plots not because I should, but because I can. I said earlier that when you're doing data visualization, you should have some fun with it. And so if people ask me to show them something interesting, I tend to have fun with it. And by that I mean that it blows my mind that I can change the background of my high charts, even if that means an animated GIF. And furthermore, I can take all those points, and rather than just use circles, because they're boring, let's use Pokemon. And yes, these are still actual points for my high chart. And so when you're dealing with data visualization and you want to see something interesting, well, interesting is in the eye of the beholder. And so if you want real big brain moves, it's not just making static graphs, which you can use for PowerPoint or Word or PDF. It's not about converting those to HTML, where you get your mouse over information or drill down information or specific tooltip information. It's not about interacting with rmarkdown, where you get layers with different tabs and viewing the code or not. It's not about just discussing it with Shiny, where you have carte blanche to look at whatever you'd like with whatever parameters. It's about building that two-way communication. Because I can build fantastic visualizations that mean absolutely nothing. So once you start to have these discussions of, well, okay, I have all these tabs in rmarkdown. Do people want to see it? Do people want more detail? Do they want to go down to SA3? Do they want to understand things? Or do they skip it all? Because at the end of the day, if you're making visualizations that aren't being used to drive decisions and actions to support them, in my opinion, at the end of the day, you're just playing. If you're looking for resources, there's a number here. I'll leave it up on the screen. These slides, the rmarkdown, is available from GitHub. Cheat sheets for R. If you're new to R, the cheat sheets gives you really quick overviews on a lot of the commands and examples of how to use some of the different tools. The book R for Data Science, there's an online version, so it talks about data wrangling, Shiny, ggplot, some of the other basic data science tools. Even though this talk wasn't focused on the data science aspects, it's a good overview for a number of the supporting pieces for your data visualizations. Leaflet, the RStudio GitHub page, has a good overview of how to use Leaflet with some examples. In particular, if you don't want to install the ASGS library, if you're going to download individual shapefiles and load them up, it has examples of how to do that. rmarkdown, the definitive guide, is a book, but again, you can find it online. Mastering Shiny. And then this blog, Data Code and Visualization. It's by the creator of HighCharter, Joshua Kunst, which is pretty neat. It's his blog that gave me the idea to use Pokemon, so it's fun too. Thank you for watching. Goodbye.